Hello geometry students, this is Mr. Butterbaugh. Welcome to our next lesson. It's titled 3-4 Algebraic Proofs. And we're going to go through a couple properties of equality and congruence first in order to use them for proofs. So let's get started. First, like I said, those properties of equality and congruence, these are things that you already know. I guarantee you already know these things. Now we just put a name to them. The first one is the addition property. If I have an equation and I add the exact same thing to both sides, that's called the addition property. So if I have a plus c, that's equal to b plus c. I add the exact same thing. If I subtract the exact same thing from both sides, it's a minus c, b minus c. If I have the multiplication property, if I multiply the exact same thing on both sides, so a times c is the same thing as b times c. I would just multiply, and c here is a constant. That's why we're saying c. I'm just going to multiply or add or subtract or divide here, the exact same thing. So divide, the division property, and then a divided by c is the exact same thing as b divided by c. And again, you've already seen this. This just comes into play whenever we actually prove what we're doing. All right, the distributive property, you know what distribute is. If I have a times b plus c, I can distribute that a to the b and the a to the c. So that's going to be equal to a times b plus a times c. Again, the distribution property, distributive property, you already know it. The substitution property, again, you already know this. If a is equal to b, then b can replace a. So if I have an equation or if I have an expression and it says that something is equal to x, then x can replace what that something is. Okay, three other ones that we have. You might not have heard this before, but we use these a lot in geometry. First one is the reflexive property. If I have something that's the exact same on both sides, I'm going to say they're equal to each other. So the reflexive property of equality is a is equal to a. Over here, if I have angle A and angle A, now angle A is not equal to angle A, but angle A is congruent to angle A. This is called the reflexive property of congruence. So two different things, reflexive property of equality and the reflexive property of congruence. In the same way, if I have two line segments, AB is congruent to segment AB. So if the same thing is happening on both sides, they're either equal or congruent. The symmetric property, if A is equal to B, then symmetrically B is equal to A. I can think of there being a mirror right here on the then part. Look at this. Conditional statement. If something, then something. There's a mirror there, so it's reflected across the exact same thing on both sides. And then with angles, if angle A is congruent to angle B, then angle B is also congruent to angle A. All right, segments, if segment AB is congruent to segment CD, I could also say that segment CD is congruent to segment AB. So symmetric property, same on both sides. The transitive property, I can transition from one to the next. If A is equal to B and B is equal to C, then I can get rid of this middleman here. B is happening twice. So I can get rid of the middleman and just say that A is equal to C. I can jump over. All right, and then with angles, if angle A is congruent to angle B, and angle B is congruent to angle C, I can just make a jump and say then angle A is congruent to angle C. Get rid of the middleman. And then with segments, if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then I could just make a jump and say that segment AB is congruent to segment EF. All right, so how do we use these things? What are these for? Let's give an example. Here's an example. Go ahead and pause the video, write this down. We're going to make a two-column proof. Write down the given, what we're proving, and then draw out the diagram. Okay, a two-column proof happens when we have two columns, a statement column and a reason problem. Statement column and reason column. On the statement column is when we put statements. The reasons are what we just wrote down, those properties of equality and congruence. So it's given that ray OB bisects angle AOC. We should know what that means. If I have the word bisect, that means cut in half. So with what's given here, if this ray OB cuts the angle in half, that means that this segment, or I'm sorry, this angle angle AOB is congruent to angle BOC. So when I'm writing my proof, I always start with what's given. So over here on the reason, I'm going to write down, I'm starting with what's given. It's given that ray OB bisects angle AOC. Okay, if that's true, if ray OB bisects angle AOC, what can I say? Well, I can say that I have two angles, and both of those angles are going to be congruent to each other. So that's number two. Angle AOB is congruent to angle BOC. And the reason for that, how do we know that? What do we know that bisects means that two angles are congruent, or two segments are congruent, or two things are congruent? How do we know that? Well, is it because Mr. Butterbaugh said so? Not only that, but by the definition of a bisector. So the reason here is definition of what bisect means, of a bisector. By the very definition, I know it's cut in two and each one's congruent. All right, if two angles are congruent to each other, the next statement I can say is that they're equal to each other. The measures are equal to each other. So the measure of angle AOB is equal to the measure of angle BOC. How can I say that? What's my reason for saying that since they're congruent, they're equal to each other? Well, that's the definition of what congruent is. By definition, congruent means the same. So definition of congruent. All right, so we keep on going then. We make more statements. Okay, and again, we're just going through here and we're listing out the things step by step that you already do. You've already done these things when we set up the equation and solve for it. We're just listing them out piece by piece in order. Since the measure of angle AOB is equal to the measure of angle BOC, I can substitute their expressions. So the measure of angle AOB is 2 parentheses x plus 7 minus 1. And now that's going to be equal to the measure of angle BOC is 3x minus 5. All right, how do I know that? What do I do? Well, judging from my properties of equality, substitution. If A equals B, then B can replace A. I just substituted what was true for those things. All right, so substitution. The next thing, well, I can go ahead and start solving this out for x. Again, remember, what I'm trying to do is I'm trying to prove that x equals 18. I already know the answer. All I'm trying to do is prove it. So I'm going to go through here and do this step by step. Order of operations, I'm going to distribute that 2 first. So I have 2x plus 14 minus 1 equals 3x minus 5. I'm just solving my equation. How do I know that? Well, that is the property of distribution. So this is the distribution property. All right, next just keep solving the equation. I got to combine the 14 and negative 1. So I've got 2x now plus 13 is equal to 3x minus 5. Why did I do that? I simplified, so simplification. Next, I want to get the x's on one side of the equation and the numbers on the other side of the equation. So I'm going to subtract that 3x from both sides. I can put that right here. Although it's not necessary when you're doing this proofs, I'm just going to put this step so we can see what we're doing. So subtract that 3x. So 2x minus 3x is negative x now. Plus 13 equals negative 5. Okay, and I can subtract that 3x from both sides because it's the subtraction property. And yes, I want you to write the subtraction property. It's actually called the subtraction property of equality, so I'm being nice, just subtraction property will suffice. All right, next step, I need to subtract that 13 over. So if I subtract 13 over, what I'm left with is negative x equals now negative 5 minus 13, which will give me negative 18. Again, subtraction property. Okay, and I can't leave it like that. I actually need to get another step in here. Because negative x equals negative 18, I need to solve for x. So to solve for x directly, I've got to divide by that negative 1, because there's a negative 1 inside. So negative x divided by negative 1 is x, and negative 18 divided by negative 1 is 18. So I do that by the division property. And there we are done. We've actually proved that x equals 18, given our 2-column proof, and we'll practice some more of that tomorrow.